Welcome to Renewable Carbon. I will tell you a little bit about carbon. Carbon is much more than CO2. Carbon is in most of our products, not only in plastic and surfactants, but also in detergents and almost everywhere. And you see in this slide here that the carbon embedded in the molecules, in the products, is mainly coming still from fossil resources. 85% coming from fossil resources, from crude oil, from natural gas, from coal, only a little bit from biomass and recycling. And the part coming from fossil resources is the main reason for climate change and also our dependency on oil imports. On the next slide we see a little bit more in details here. The total volume of carbon we need worldwide in our products are 450 million tons carbon per year. And in the different sectors like here, thermoplastics, man-made fibers, or also solvents, you see here are different shares. The gray part is always the fossil carbon, the orange part is recycled, and the green part is bio. And in some areas we have already high shares of bio-based carbon. And when we look into the total demand today, most of the carbon is used for energy and transport, and only 10–15% for chemicals and all kind of materials. But until 2050, this picture will completely change. We see here in transport minus 90%, electric cars and hydrogen will take over, and we will have not so many gasoline diesel cars anymore. Also in energy, we have new systems for heating, solar heating, also hydrogen. But the demand for chemicals materials will increase. And there we cannot substitute carbon by hydrogen or electricity, because we really need the carbon molecule in our chemicals and materials. And we need a strategy for this transformation. And we look into specific sectors important for Clariant. For example, the market for surfactants in the European Union. We see there is a total production of 3,000 kilotons per year, and 50% of it is already bio-based. So we have here a very high share on biomass utilization. This will even increase. And we have also calculated here the carbon demand. And the demand for bio-based carbon today is already something like 1,000 kilotons or 1 million tons carbon per year. And this will increase more and more increasing the next decades. And so we can in this field more and more substitute the fossil carbon by biocarbon. And this picture shows the turnover. And we see that some sectors are very important in the economic field, like paints here or perfume, soap, detergents, having important turnover in the European Union. If we go into bio-based, this turnover will more and more go to biomass and not anymore to crude oil. When we talk about renewable carbon, we're thinking about everything what can be substitute the fossil carbon. So our definition is renewable carbon entails all carbon sources that avoid or substitute the use of any additional fossil carbon from the geosphere, or we can also say from the ground. That means the carbon we can use in the future, renewable carbon, can come from the atmosphere, from the biosphere or the technosphere, but not from the geosphere. Renewable carbon circulates between biosphere, atmosphere or technosphere, creating a carbon cycle economy. Or like the European Commission was communicating last December, a sustainable carbon cycle. And this is the world, how the world could look like if we are successful in the transformation from fossil carbon today, 85%, to zero fossil carbon 2050. And here we have three options. We have the option of recycling, so everything, all our materials or products entering the technosphere can kept in a cycle. We are recycling. We have very advanced mechanical recycling today, but in addition, we also are talking about chemical recycling, where we can break down the materials to some basic building blocks, and then we're creating virgin quality new polymers. Then you see the next one here, 25% CO2 based. We can also directly utilize the CO2 from the atmosphere or from emissions to produce chemicals from it or surfactants from it, all kind of chemicals. This is a complete new pathway, but we see this is also a great option for the future. And last not least, we need biomass. This 20% share in 2050 seems not be so big, but compared to today, it's more than 10 times more than we're using today. And some experts think we can do the whole covering of this demand, this increasing demand for chemicals by biomass. But here we have to be very careful because biodiversity is a huge problem so far, not only climate change, also biodiversity loss. And so if we're using too much biomass on our planet, we're getting a lot of conflicts with biodiversity. But if you see this picture here, it's not only showing how the demand can be covered in 2050, but you see also in this picture how this demand is growing from 450 million tons carbon today, embedded in the molecules, in the material, up to 1,000 million tons carbon in 2050. And the main reason for this growth is that we have a worldwide population growth. We have also higher income in many countries, so the people will buy more products. And so we will see here an increasing, lasting demand for carbon. And here is a scenario how we can cover this demand without taking additional fossil carbon from the ground. But to come to this picture, we need a lot of investment, we need innovation, and also the right political framework. And we know that Clariant is working very strongly on this vision. And just another example, when we look into the plastic sector, this picture shows how it could happen in 2050 if we do the right political framework and also the right investment in innovation. But this picture shows also that also in plastic, even if we try to keep the whole plastic waste in a cycle, we will still have some losses. Now, this here is a very optimistic picture that we can keep about 70% of the plastics in a cycle. So if we're losing 10% in the production, 10% in collection, it's a very, very challenging, and 10% in the recycling process. But still, if we are so good, today we have not 70%, but perhaps 10, 15%. So when we are really so good, we have still a gap of 30%. And this has to be filled by biomass and CO2, also to avoiding any additional fossil carbon in the cycle. This is a picture which shows the future, how the future could look like for energy and for materials. The left-hand side, we see the well-known picture of energy, solar, wind, hydrogen as an energy carrier and the storage, but also a link to the right side of the picture where we see the renewable carbon for chemicals, plastic, and all other kind of materials, carbon of CO2, biomass, and recycling. And there's only a small pathway from the right picture, blue picture, to the left one. This is kerosene for long distance flight. Here is the only application in transport where we will also need carbon-based fuels in the next 20, 30, 40 years. But on the left-hand side, we can decarbonize the energy system. On the right-hand side, we should not talk about decarbonization because it's about carbon. Here we should talk about defossilization, that we need carbon, but other carbon than today. And my last slide shows some information about a huge conference coming in May. 3 days on all options on bio-based, CO2-based, and recycling, offering the latest innovation. And this renewable material tree is showing that we can keep all our products we love today. You see here a lot of different products made from carbon, but we can keep this product, but we can decouple this industry completely from fossil system. We can base the whole system on bio, CO2, and recycling. And this is really a bright future. So chemical industry, material industry, without any additional fossil carbon going to the atmosphere. Many thanks.